Welcome. Thank you so much for coming here. Today I'll be talking about Invoke-DOSfuscation, techniques for fin-style DOS-level command obfuscation. My name is Daniel Bohannon. I work for Mandiant FireEye out of Washington, D.C. Super stoked to be here in Paris. What I do at my day job was originally incident response consulting, and now I do applied detection research, which usually means tracking down threat actors all around the world, and then also causing more troubles for us as defenders in researching obfuscation techniques to better be able to detect the things we haven't even seen before. A few of the projects I've worked on before include Invoke-Obfuscation and Invoke-Tradecraft obfuscation for PowerShell. I co-wrote Revoke-Obfuscation for detecting obfuscated PowerShell. I did that research with Lee Holmes from Microsoft. And then what we'll be talking about today, Invoke-DOSfuscation. So a brief disclaimer, none of the stuff I'm talking about is outing any particular client or client group. Most of the stuff we'd never seen before in the wild before I released this research, but just a general disclaimer. So today, what I'm going to start with is kind of a high-level overview of the state of obfuscation and the way that we see it being played out amongst threat actors. And then we're going to dive into 3 case studies that really defines kind of how I happened into this area of obfuscation research over the past year. We're going to look at a couple different areas of command.exe obfuscation. And then we're going to kind of put all those pieces together for some crazy payload encoding, all with the wonderful CMD.exe. Then we'll do a demo of the tool. And then lastly, we'll look at detecting this kind of obfuscation. So first, a state of obfuscation. From the red team's perspective, obfuscation is great. It's a cheap way to evade a lot of rigid detections. You don't have to change the core of your payload. If you're not being detected based on heuristics, but off of syntax of the payload or the command itself, then obfuscation is a great way to evade those kinds of detection techniques. And there's an obfuscation framework for free for almost any language you can think of. And even though I may be biased, I don't really see it slowing down anytime soon. From a blue team's perspective, we've actually seen some really significant improvements in visibility from a defensive perspective. Things like Microsoft's anti-malware scan interface, ETW, which is event tracing for Windows. A lot of these things, some have been around for a long time, but it's giving defenders today more visibility than we had before. However, attackers are, they're not stopping. They're improving, and they're countering this in one of a few ways. They could just choose softer targets. Say, OK, well, that's great that you have this great defensive visibility. We'll just go after this target and this client that doesn't. Or they're just disabling this defensive visibility. Or they're just going around it and saying, OK, PowerShell has gotten incredible in terms of visibility and script lock and module logging and all this great stuff. So why don't we just use JavaScript or C# or just crazy idea, but maybe we'll just compile our own binary and drop it on disk because not many people are actually doing application whitelisting. So they can just choose a language that doesn't have this visibility. So at this talk today, typically I've talked about PowerShell obfuscation, but this is completely about command.exe. And a lot of detections today are based, for command.exe, are based primarily on process called CMD.exe and contains arguments of this or this or this. Other things are like parent-child process relationships. So maybe Explorer spawning command.exe could be interesting, but Windward spawning command.exe is a bit more interesting. And so kind of the context around who is spawning the process. And then also looking at command.exe as like a source of action. Command modifying a registry key directly or writing a file or reading from a file or something like that. So the case studies that really led me into this work. My manager, Nick Carr, he and I wrote this blog post back at the very end of June last year. And it highlights some interesting in-the-wild obfuscation techniques that we saw used by 3 different threat groups. Financial groups Fin7, known as Carbonac, Fin8, and then APT32, also known as Ocean Lotus, out of Vietnam. So the first one is Fin8, and when Fin8 does some really cool stuff. This was actually a deobfuscated macro payload where they were setting the very bottom. They have this PowerShell command they set into one environment variable, and then they had PowerShell dash in another environment variable. And then the actual command, the only thing you saw spawn from Windward was the very top command, command/c echo var1 pipe var2, which is piping the actual PowerShell command into PowerShell dash, which runs a child process of PowerShell, invoking the contents passed in as standard input, which is a great way to keep your payload off the command line. The next one was APT32 2 months later, and they were using Casey Smith's squibbly-do usage of redserve32.exe to download a remote SCT payload and execute it. And so originally we saw them using the command.exe's caret characters, which are the escape characters, to break up detections that are looking for /i:/HTTP. But then we saw them using the double quote. And this is something I tweeted about a couple times over the past year or two, that the double quote is such a more effective obfuscation character than the caret for a lot of reasons, and we'll see that a few slides in. But it was cool to see them actually use it. And they didn't just spray it all over the entire command. You could see they were very intentional about where they put these obfuscation characters. And so for me, I really appreciate this because you actually understand the effort of what they are trying to do. So I kind of call this more tasteful obfuscation as opposed to just like obfuscating everything. And the last one, this one example single-handedly started me down the path of this research. So Fin7 and APT32, they really compete for first place in my heart when it comes to like the coolest, most tasteful obfuscation. Like they're really creative. And so in this payload, this was extracted from a malicious link file that was dropped to disk. And so the two portions, they have some JavaScript encoding because they're echoing out a JavaScript content to a file. And so, for example, instead of having eval, they had this nice ASCII conversion and then adding in V, A, and L. But the two portions in the red box, when I saw this really confused me. Because I've been digging around for a while looking for interesting characters like the double quote, the caret that you can use and break up commands. But I didn't understand this part. So this command is command/C, and then it's setting this process level environment variable x. And it's setting this VBScript command in that variable. Then you have the part where it's writing out a file, and then you have the end where it's echoing the variable x into command, since command can also execute what's passed in as standard input. But what I didn't understand was these delimiters they were using. I'd never seen the at character, and they put that in VBScript and JScript. Now, if you copy and paste this command, that actually doesn't work. Those at signs don't function properly in that context. What I noticed was that when they called %x at the end, what they did was they actually made space after the variable name, and then they put in this syntax right here. And what this does is this is a string replacement syntax native to command.exe. So you have the colon after the variable name, and then the string leading up to the equal sign, it finds and replaces every instance of that string with whatever's on the right side of the equal sign. And in this case, there's nothing on the right side. So what it's saying is, yes, I know that this variable contains these characters, but in memory, I want you to remove them before I act on the variable. Now, what finesse. Holy cow. When I figured this out, and this took me about a day of just looking at it and trying to figure out what's going on here, I was so blown away by how cool this was. So the timeline of this was we found this payload on a Wednesday. We figured it out that Thursday. Me and Nick wrote this blog post. We got it published on a Friday. I was still so jazzed about that technique that I was like, I want to write a POC about this. So I went home and spent all weekend, and I pushed this POC called out fin-coded command, like fin style encoded, and I pushed it out. And then as soon as I did, I kind of sat back and thought, I wonder if there's more here. Like, this is just one character, but how long has this been available in command.exe? And I never knew it. Like, I wonder what else could be there. Is this worthy of actually some significant research time? And after about a week of initial research, I realized I was hooked, and there was a lot here to uncover. So to defenders, I would say this has some pretty interesting implications, both for dynamic detections, looking for like command arguments like upon process execution, or even those artifacts in like your sysmon EID1 or security EID 4688 process execution logs. But it also has implications for static detections as well, looking for these payloads in the registry run keys or in service image path, or even in like batch files or other sources like that. So what we're going to do by the end of this talk is you'll have mechanisms in which you can take any input, any arbitrary input command, and start to add layer upon layer of obfuscation and get something like this that still works perfectly fine. So hang on tight. We're going to move really fast. All these slides are online. There's also a 36-page white paper that I put together with all this on there. It's basically these slides minus the fun memes, so there was some kind of give or take. But all the information is there, and what we're going to do is we're going to look at all these building blocks, and we're going to stack them all on one another, and at the end be able to do crazy encoding using just command.exe. So first, let's look at binary name obfuscation. This will be brief. A lot of defenders they write rules that say the process name is command.exe and blah, blah, blah. Some attackers like to just rename binaries. So if they rename command.exe to benign.exe, then you lost all your rules, unless you're looking through some other means, looking at header information to see this is actually still the original file name is command.exe. There's also command, but that's not what we're talking about. There's also command.exe substitutes like PCA Lua, 4-file, script runner. Some are Win10 only. But basically, there's a good list going here. Kind of the new term now is law bins, I guess, of LOL, living off the land binaries. But basically, other things you should look for. So if you're only looking for WinWord spawning command, what if WinWord spawns 4 files and then something else? Like, we need to be aware of these additional binaries as well. But that's also not what I'm talking about. I'm talking about, from a command argument perspective, what are pure syntactical ways that we can have a binary name, like PowerShell and command. Those are the 2 examples we'll look at here. So one way you can do this is using environment variable substrings. So for example, to get the string CMD, if we echo program data, assuming that C drive is your home drive, which is an assumption, not every system is like that, we can say, let me take the substring of 0 index and go forward 1, and then index 9 and go forward 2, and that will be CMD. And now if we run that on the command line, it reassembles it, and that's what the command is. And the bottom example is using PowerShell. Now, what's important here is that if you copy and paste this into command.exe, when you look at the logs, none of this obfuscation is still present because it's an existing environment variable. So if you want to get the real value out of this, you have to use non-existing environment variables because they don't resolve the same way in the command line in certain contexts, but we'll get to that. But an interesting way, I was trying to figure out, well, how can I have an obfuscated version of these binary names but not have it resolve in the command line? So what I came down to were 3 internal commands: set, assoc, and ftype. Set will show you all the environment variables and their values. Assoc and ftype are actually related. Assoc shows the association between an extension and then the type of application that goes with that extension. So like ACCDA is access. And then ftype takes that association type with the binary and arguments to actually run it. But the reason that I came down to these were they're internal commands, so it's not spawning another process. But somewhere in the payload, you'll actually find the string PowerShell or CMD in the text output. So let's just use set as an example. If we run set and grep or find string for PowerShell, we'll see we find the string PowerShell in the path and PS module path variable. People's path variables are probably going to be different on each system, so let's actually go with the PS module path. It should be a little more consistent. And this screenshot on the bottom is actually a snippet from my code. So whenever I write obfuscation frameworks for fuzzing and things like this, I like to take a lot of options so that you never get the same option every time you run the tool. So all these substrings, if you actually put that in with findString, it will return PS module path. So now when we return this, this is the value we get here, the paths to the PS modules. And what we want to do is actually figure out what delimiters are on each side of PowerShell so we can just like lift those values out. So the lowercase s and the backslash are the delimiting characters around each instance of PowerShell. So if we delimit on those characters, that actually breaks up this string into 13 pieces, but we're interested in piece number 4 and number 11, which is PowerShell. So the way that we can do this with command.exe is to run a command and to capture the output into a variable, we use the for loop. And the for loop will let us run, in the end, our set find string PSM to get that output. And then what we'll do is we'll define delimiters within the for loop because it gives us that option. And we'll say the lowercase s backslash delimiters, and we want index number 4. And when we do that, we'll see that it pops out the string PowerShell. And we execute what comes out of that result. So now on the command line, for the initial command, PowerShell is nowhere to be found, but it actually pulls it out of memory based on this for loop and the delimiters that come out of it. Now in this example, well, obviously PowerShell is going to be the child process. So you will see PowerShell in that regard, but what if your command actually isn't a separate binary? This actually opens up some really interesting opportunities. So let's keep going. That was just ways to obfuscate the binary name. And this is important if you, say, are looking for registry run keys that have the string PowerShell in it. Well, in this case, it's nowhere to be found there, right? So it has a bit more implications for static detections, but still implications for dynamic. So character insertion obfuscation. What are characters that you can put all over the place for command.exe and really mess up detections? Well, the caret character is the most common one that we see attackers use, which is the escape character for command.exe. So if you escape something that has no escapable meaning, then it does nothing and the command runs perfectly fine. We saw APT32 using the double quote characters, which are even better because you don't have like half-life. If you use the escape characters, then you lose one set of escapes, or like one layer of escaping every child process. But with double quotes, they go all the way down. And they even go down into processes that wouldn't normally process the double quote, but since command.exe is the parent process, you're good to go. Encapsulating parentheses. So I first saw this while investigating some newscaster activity, and I don't think they were using it for obfuscation purposes, but basically you can put any amount of evenly paired parentheses around commands and certain subcommands as well. And this will come into play if you have detections looking for like anded or ored commands that assume there's only going to be white space between those ands and ors in the next piece of the command. But now you have to factor in parentheses as well. And it actually gets worse. So after I discovered this, I wrote a fuzzer to say, well, let me just create a bunch of commands and insert random characters somewhere in the command and see if I can find other characters that do the same thing. And so I came across, through that process, the comma and the semicolon. And before releasing this research, I'd never seen this used in the wild, and I looked a lot. But the command and semicolon can be used in the place of white space, all three serving as delimiter characters. And we'll see all the places where that applies, where you can use these, and this is really, really cool. We already saw standard input hiding, echoing content into command or PowerShell. Non-existent environment variables. This is one I found in a blog from several years ago, where for batch files, this is really only a static thing. For batch files, if you use non-existent environment variables, they'll just resolve to nothing. And so it's a way you can obfuscate your payload on disk. Custom environment variables, and then existing environment variables we looked at previously. So when I released the outfin-coded command POC, I included some of these obfuscated versions using the environment variable substrings for command and PowerShell. And then within a few minutes, someone replied on Twitter with a full command that was just this encoded stuff. And so in the tool Invoke-DOSfuscation, you can feed it any input command, and one of the options is just environment variable encoding. And it'll go through and randomly select environment variables and the characters in there and produce payload just like this. So after looking at this part of the research, I started writing UR rules, scraping internal, external sources, writing all different kinds of signatures to see, do we actually see this in the wild? Have we seen it in the wild? And for environment variable encoding, the answer is yes, and for a really long time. This sample is a malware called Devourer from 2012, but it goes way back, a lot older than that, using environment variable substrings. Here's another one where instead of just using known environment variables, they set a custom dictionary into a custom variable, and then the rest of the command is just substrings of that custom environment variable. We've actually seen an interesting Chinese APT group use this. Pretty interesting stuff. And this is from a tool called JS Batch Obfuscator on GitHub. It's like the smallest obfuscator I've ever seen, but it's amazing. It's a really fun tool to use. Go check it out. And this last one, there's a lot more details in the white paper about some of the political nature of this fish that this payload was in, but batch encryption is a really interesting combination of existing and custom environment variables and a lot of other stuff. So I'll leave that one to go check out in the white paper. So I've talked about binary name obfuscation, talked about these different insertion character obfuscation components. So what if, as an attacker, I know that the company I'm going up against is looking for these characters. They're looking for the carets, they're looking for the quotes, the commas, semicolons, all these things, and they're really good at detecting it. So when I'm thinking as an attacker this way, I wanted to figure out a way to obfuscate a payload without having to rely on any of those characters. So let's take this example. This is just a netstat command, but the first portion, if there's any defenders in here, that first portion of the command should look really familiar. And this is like one of the most SIGable things in the world. Metasploit uses this, a lot of tools use this. ComSpec in and of itself should be pretty a big flag, but /b, c, start, b, min, a really common set of arguments. So I wanted to use this really common example to show how you can mess with even really good signatures and indicators, right? So it's good to know what the arguments are. And sometimes you can just drop one of the variables and it still runs perfectly fine. So here's kind of a description of some of those variables. The one we want to focus on is ComSpec for right now. So ComSpec is the path to cwindows system32 command.exe. So two ways that we can obfuscate this are using environment variable substring and substitution. So the substrings, as we already saw, this value is 27 characters long, which means that we can do substrings and define start from 0, go forward 27, or just start from 0 and go forward till it's done. And you can also do negative indexes, negative 27 as well. But actually, it doesn't really matter how long the payload is. You can use values that are much larger than that, and it still works fine because it can't go past forward or backward the actual value. So negative 1337 will still produce the same full value of this path to command.exe. You can also do environment variable substitution. And with this, you can choose variables or characters that actually exist, like converting backward and forward slashes back and forth. Or you can choose values that aren't going to exist anywhere. But it doesn't matter because you're not actually trying to change it. You just want to break up %, because if that's what a defender is looking for, then they're going to miss this. And so let's just take 2 of these examples and keep obfuscating. So you can randomize the case for any variable that has no effect on it. You can also add a lot of white space. And for this bottom example, it actually does change the behavior of it, but in this case, it doesn't matter because we're not trying to change the value. And then you can also explicitly assign integers in command.exe. So I don't know if you've ever seen a -0 or +0 on the command line, but this actually has some really interesting simple detection wins if you are randomly adding signed operators to your integers. So we'll go with the second option and throw it into the command. Now, a really important point here is that context matters. So if you try to copy and paste this into something that's not a command.exe context, it won't work. Because the comspec variable works as a run key or service because the operating system will kind of find and replace that with the full path. But it doesn't know how to interpret this weird substring and string replacement syntax. So you have to be in a command.exe syntax if the very first part of the command is actually obfuscated in this way. But if you start with command.exe, and then the rest of the command can be obfuscated with this, no problem. So for the rest of the command, we can randomize the case with those flags. An interesting thing is that with BC start bmin, you can actually remove all the white space between those arguments. Now this actually gets really interesting with a lot of detections that assume you have to have a white space / something white space. And another important note here is that in between the comspec variable and /b, there's no white space in our command. But when it actually runs, the operating system inserts an extra white space there. So when you look at a live running process or even evidence in the process execution logs, there's an extra white space. So now what this means is, hey, maybe I have a detection that works great looking for this statically in registry, but the operating system may actually change something in the evidence I'm looking at later. So do I need to change and have 2 different detections for both or make it robust enough to cover both pieces? So we'll just reorder that ANO to NOA for fun. You can also add a lot of white space between all of these. And then remember, anywhere there's white space used as a delimiter, you can add commas and semicolons because they also serve as delimiter characters. And you can add as many as you want. So now it starts to get really interesting. Maybe you were doing regex is looking for /b, /s* for any amount of white space. Well, now you have to take into account white space, commas, semicolons, maybe some other stuff as well. Let's keep going. You can add all those characters in places that it doesn't matter. And then when you actually run that, the process execution is going from the bottom up. You'll notice that the carets are losing 1 layer every time they go up. And this portion highlighted blue, we'll look at this in the detection portion, but whenever you see command.exe space /s space /d space /c 0 space double quote space and then the command. I know that was a mouthful. This is actually an artifact of the operating system when you have subcommands and a few other weird scenarios like piping content from standard input into a binary. What that means from a defender's perspective is whenever you see this command, it's actually going to be an artifact from the OS, and you automatically have context around the arguments that it was either a subcommand or was pushed in a standard input. So when you look at all these obfuscation building blocks, these operating system artifacts are actually really helpful in detecting some of these. But what you'll notice is that our final netstack command doesn't have any of this cool obfuscation in it. It just has the casing and white space. But why did none of the other characters work? Well, the comma and the semicolon and the caret actually aren't compatible with this netstack command. But the one character that is the double quote. So now if we put double quote in the original command, it persists all the way through and we get it into our final commands, which is awesome from an evasion perspective. But this is really difficult, actually. So in the PowerShell obfuscation I've done in the past, you had the benefit of using PowerShell's tokenizer to be able to say, given this crazy garbled thing, what's the command? What's the string? What are the arguments to kind of tokenize it and inform you about what the whole thing is? Well, there's none of that for command.exe. So I call this my sad little violin slide, looking for a little bit of sympathy. Not really, but it was just a really interesting problem to try to solve without having these cool tools that PowerShell made available. So it was a much more rigid detection problem to solve, but it definitely made for some interesting challenges. So again, a defender may say, well, I don't care about any of this stuff. You ran netstat. I don't care if there are ticks or quotes in the arguments. I'm still going to detect that, so I don't really need to care about any of this obfuscation stuff. Well, I would say 2 things. One is I think detecting obfuscation in and of itself is valuable because that tells you something about intent. If something is obfuscated, I immediately am more interested in it and want to know what was trying to be hidden from me. And the other reason I'd say it's important is that an attacker could do a lot of things that if the whole command was obfuscated, and let's say it never spawned a child process, like all these things, they don't spawn a single child process, then you'd miss that unless you were looking for obfuscation in and of itself. So if you're actually having attackers on the command line in obfuscated fashion renaming binaries, or maybe reading files or doing directory listings, or I don't know, maybe sinkholing your cloud-based security solution by dropping something into your host file. These are all things that we should care about as defenders. That it's never going to spawn a child process. And if attackers are using this DOSfuscation stuff, then we're not going to see it if we're not looking for the obfuscation in and of itself. So in all this research, basically, it came down to 4 different ways to encode an entire payload without using any of these special characters, without having to use them, but you have the option. The first one is concatenation. So let's take this netstat command. A fun fact, whenever you have arguments that start with a dash, you should try to replace them with a slash, because a lot of times that works, and a lot of defenders are only looking for one or the other. So if you look at VBScript no logo, that can be 1 or 2 slashes, or it can be a dash. Or if you're looking at PowerShell nani slash or -enc, you could change those to slashes as well. I very rarely see this, but it totally works, and it evades a lot of rigid detections. Regserve, you can also do slashes to dashes. Also, if you look at URLs, you can do // to back. And in some languages like PowerShell, you can do forward, back, backward, forward, and get really crazy really fast. So whenever you're writing detections, if you're writing // ask yourself, can these actually be reversed, or can I swap these with dashes? And those are the kinds of things that really make rigid detections move into more resilient, robust detections. So we're going to set our payload into this com variable, and then we're going to echo the variable and see that it actually doesn't resolve the value. 2 ways we can use to resolve the value is to spawn a child process, or we can use the call internal command to resolve that variable. So let's just use call. And if we do that, then it runs netstat. Great. Well, now, why don't we chop up our command into 3 pieces, com1, com2, and com3. And then we'll call the concatenation of those. And what's interesting here, and I wrote a blog post on this, is that if you're using sysmon as your data source, there's actually a parsing bug in sysmon that has to do with % signs. So I'll leave that for later. But basically, if you're using sysmon as a data source, definitely check this out. There's a couple different ways this can mess up, particularly if you're using event viewer or PowerShell's get when event to view sysmon EID1 logs, specifically in the command line field. So it's important to test your defer tools, know your data sources, and check against a couple different tools and sources to make sure that the stuff you're writing your detections for is actually valid. We can also reorder the substrings as long as we reorder them back at the end. And let's keep going. So when we actually set it into a final variable and call that, there's a couple different options we have in the tool. One, we can just say call final, and just in that same session, we can execute the results. If you have certain special characters like pipes, then that call variable actually expands it, and in that context, it tries to actually push the contents through the pipe. So in those cases, you have to have the second option, which is spawning a child process to call the variable, or echoing the variable into a child process. And it's a little sloppier since you have to have a second execution, but there are some things to be gained from having that child process, particularly when you're using the standard input option. Options 4 and 5 are the same as 2 and 3, but instead of command, it's using PowerShell. So in the tool, I basically give you the option that if you want to run a straight PowerShell command, then it will handle DOS-level obfuscation that then wraps around PowerShell-level escaping of that obfuscation, both for PowerShell and for command.exe. So it's like it gave me a lot of headaches, but that's there because attackers also like PowerShell, and I'm a bit obsessed with PowerShell. So this doesn't have netstat anywhere in it in the arguments itself, and we didn't use any special characters. But if you wanted to, you could totally do that. So you could randomize the casing, you could remove white space, you could add white space, you could do commas and semicolons, tons of carets, and even parentheses if you wanted, and it would run just fine. But you still have netstat in the arguments. OK, well, we saw before we could use those double quotes, right? Boom, double quotes works perfectly fine. If you'll notice that the double quotes are side by side. So a really interesting challenge came, what if I want non-adjacent double quotes, like that second option? This was extremely challenging because there's no way to actually escape double quotes in command.exe. So we can't do this. This actually fails. So the solution I came up to this was a 4-part solution, because we have to have evenly paired double quotes throughout the entire command. So the first step is anywhere where I want a non-paired double quote, I make it paired. So we have quote, quote, and then later quote, quote. Next, I'm going to set a custom variable, let's just call it quotes, and it is the value quote, quote. Third, in the final variable, I'm going to use that fancy string substitution that command.exe has and say anywhere where we have quote, quote, I want to replace it with 1 double quote. But if I put 1 double quote here, I'm now unbalancing the whole command, and it doesn't work. So how can I have in memory it be an odd number of double quotes, but on the command line an even number? And the answer is I can take a substring of the quotes variable and just get one double quote. But this doesn't work because the percents for that quotes variable are inside of the percents of the final variable. So this got me thinking, is there a way that and this doesn't work because the percents get all mismatched. Is there a way I can extract a variable value without percents? The answer is actually surprising. If you're running Vista or later, you can use this flag Vista. With the flag Vista, you can then use exclamation points, and this resolves the variable. So now exclamation points for the quotes variable inside of percents for the other variable, and our command works perfectly fine with unpaired double quotes. Awesome. Now, I have to admit, this is a little bit of a troll. There is no such thing as the Vista flag, but that command does work. And the answer is, if you look at Command's help menu, there is this v-on, which is for enabling delayed environment variable expansion. But what I found is that you can do v-on, v-o, v-colon. As long as it's not v-colon off and a couple other weird variations, you can do v literally almost anything under the sun, and it works. Now that's weird, right? So other things you can do is obfuscate environment variable names to be special characters, or even white space in differing lengths following any one non-white space character. So if you're a cruel attacker, you can get pretty nasty here. So dude, you call yourself a defender, but why you do this to yourself and to the rest of us? Well, I started with concatenation because we've already seen baby steps of this being done in the wild before this research. And typically it was in the context of malicious link files, concatenating PowerShell, sometimes having garbage concatenations in there. But yeah, this is stuff that we've seen attackers do just for one string of a command, but we'd never seen them apply it to a whole command before this research. So the next three we're going to look at are things that we've not seen anything at all in the wild for. And when I say that, what that means is that for the 9 months of research that went into this, I was looking across public and internal file repositories, sandbox execution reports, and writing detections for over 10 million endpoints all around the world and all of our clients to see, do we have any of this kind of stuff going on in the wild? And we didn't see any of it in the context that we're talking about here. So number 2, we talked about concatenation. What about the for loop? For loop is really, really interesting. If you go to the command help menu, when we look at that v-on for the variable expansion stuff, it also says the var syntax expands variable, blah, 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 which is quite a different thing when inside of a for loop. That is an understatement. The for loop gives you crazy cool capabilities. So let's check it out. Let's go back to our netstat command. We want to make sure we have that /v for variable expansion. And for /c, so when attackers rename binaries, I don't like to rely on binary names in any of my detections. So /c has always been a nice kind of anchor to say this is potentially a command execution. We're looking for like /k or q or some of that kind of stuff. But if you actually look, if you look in Command's help menu, if you scroll down, for compatibility reasons, /r is the same as /c. What? Is that true? Surely you can't just replace a /c with a /r and it works. Turns out you totally can. And the way I remember these anchors are CRV. You have /c and /r, which is the typical C flag, and then V for variable expansion. So CV and R are really interesting to look for. This is also an amazing troll opportunity. Remember how we could put anything we wanted to after that /v? Well, any space leading up to that /r or C, you could put anything you want in there. Like this command actually works. It doesn't show the GIF, but that's crazy, right? Like attackers should be putting funny messages to us defenders to make our, brighten our days a little bit, right? What if you have an analyst that sees this? Do they think it's just echoing the path variable? What about all this white space down to this other command way down here? That's because /c has 0 meaning. /c is what we're looking for, or /r in this case. So if you run this, netstat actually runs. So if you're doing analysis and hit review and your horizontal scroll bar is really small, you should probably scroll over or just enable line wrap so that you're not missing some payload that's like 1,000 characters down the line. And command.exe has a command line argument limit of 8,191 characters. That's a lot of space to work with. So anyways, as an aside, let's get back to it. What we can do is set the unique characters for our payload into a variable. Let's call it unique. And then in the for loop, we're going to set the indexes for our payload. So to form netstat, we need 0, 1, 2, 3, and the rest for netstat space tag ANO. And then we're going to set a delimiter that is not any of those values. And then for each item in the for loop, we're going to set the substring of that variable, of that index, and we're going to append it to a new variable called final. And then we're going to execute final if we hit that endpoint delimiter. And so this goes through interactively in standard output. You'll see every iteration adding one character at a time to the command, but none of it hits command line arguments. So it looks something like this. It's actually fun to watch. It's kind of like the Matrix as it scrolls down. And then if you want to up the game, you can add additional characters in there and adjust the index values as well. And as with any of the other ones, DOSfuscation will automatically add the white space, commas and semicolons, carets, parentheses, and, for fun, explicit signing of integers. So it can get pretty crazy. And there's another troll opportunity here. In the tool, you can actually put custom messages to start your unique variable, and then any characters that are missing from your actual input command, it'll just add those at the end. So again, there's nothing to say attackers can't have some fun and make defenders' jobs a little interesting and happy during the day. The third one is reversal. This is also using the for loop, but using the /L. So instead of having to specify every index, you just have the start index, the end index, and then the decrementer or incrementer to basically traverse in forward or reverse. And so there's other similar things you can do to make it a little more complicated. Kind of go through here. I'll skip that. The last one is fin coding. So we talked about concatenation. We then have the for loop doing for coding or for loop encoding. We just looked at reversal. And then fin coding is what the original POC was kind of the fin coded command stuff. But there's a lot of things that I learned that made this a lot better over 9 months of research. So basically, you take commands like let's take every T, let's replace it with a capital Z. And then later, let's replace capital Z in memory with lowercase t, and then execute that sub1 variable. And then we go through another layer, and let's replace all the A's with 7s, and then later replace the 7s with A's, and then execute that variable, and go as many layers deep as you want. So on the bottom is an example from the original POC. Now at that time, I didn't know about /v for expansion. So every single substitution, I spawned the child process. So this child process tree was like command, 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 command. And because of that, I had to escape all of the ampersands. So I had 1 layer of escaping, 2 layers, 3 layers. So basically, after 3 layers, it was like half your command was carets. It looked really bad, really obvious. But none of that is an issue in the new form because variable expansion makes that really easy. So let's look at a demo of the tool. Please don't use this for evil. And if you're Fin 7, 8, or APT32 and define evil differently than I do, just don't use it all. I know you still will, but I still say it. The code is up on my GitHub. And again, any input you have, there's a couple different things you can do with it. If you know me, I love animated ASCII art with any of my tools. So this is the intro, kind of like video. When you run the tool, just doing a little bit of fun. Colored obfuscation there. And then it uses the same menu as the PowerShell obfuscation tools. So there's a tutorial, help. Anything in yellow will take you to a new menu, and green actually executes something. So you can set your commands, set your path to your commands. You can set the final binary to be command or PowerShell. The first option is just binary. So if you want to get that weird obfuscated syntax for command or PowerShell, then you don't have to put any input in for this. It'll just spit out this obfuscated syntax. So this is using the for loop to create the command PowerShell. If we paste it into command, we'll see that it runs PowerShell just fine. So that's the binary section. The next one that we'll look at is actually entering a command. So in this case, we'll just set a command. So we'll do set command, and we'll do ping 8888. And then we'll go to encoding, and then add some encoding layers. At any point, you can do show or show options and see what command you've set, what obfuscation options you've run, the length of it, et cetera. And there's kind of profiles, like 1, 2, and 3 of like low, medium, high obfuscation. If you go into the underlying functions, you get a lot more options. And when we talk about the test harness for defenders at the end, then you'll see that it actually utilizes all the capabilities of the tool, whereas the interface, which is typically what script kiddies are going to use, is going to be a limited set. So lastly, let's set a PowerShell command. So we're going to set our command, and they're also going to say set the final binary to be PowerShell. And as you can see here in show, we have our command configured to PowerShell. Everything's good. So we go into the payload obfuscation, and we'll do concatenation. And there's just a plain option 1 is going to be 0 additional special characters, but just do exactly what you ask. So that's concatenation. Or you can do option 3, which is going to be not the craziest obfuscation, but crazy enough to make a point, which there's your payload now. So if we copy that, then it runs PowerShell, and there's your command. So for me, when I was trying to debug this, I figured, what's the worst possible thing I could have to deal with all the weird fringe cases? And I thought, well, maybe if input was obfuscated PowerShell command from all my other tools, that would be like my worst nightmare. So I basically built unit test and made that my worst nightmare, and it still haunts me to this day. So I took this payload, hosted it this bit.ly link. I ran it through Invoke-DOSfuscation to get an obfuscated PowerShell downloader. I then took that obfuscated content, ran it through Invoke-Obfuscation to obfuscate over token layers. I then took that output, ran it in through Invoke-DOSfuscation to get this for coding. And this is this is the result. And this takes about twice as long as what it should because my VM was like struggling hard with all of this. But all this is in standard output. None of it hits command line. And this goes on for a while. Let me fast forward just a quick second. It's getting close. It's getting close. Does it work? PowerShell TAC? Yes. It works. I mean, it's a demo video, so you know it's going to work, but that took way too much time to make that work, but it does. So, for the blue teamers, how do you detect this stuff? I have tons of information in the white paper on this that goes into much more detail, but some high-level things, you can look for the presence of these special characters, but there are plenty of tools that legitimately use them. You can also look for, this is actually really valuable, is looking for these internal commands, like figuring out what are the building blocks to make all this stuff work. Because command is very rigid, so there are only a certain set of building blocks you need. So why don't I look for the presence of those that are then broken up by certain obfuscation characters. Looking for substring syntax, also for loops, and again, the white paper has some sample regexes, even some PowerShell functions to make that a little bit easier. I suffer from FOMO, which for me is the fear of missing obfuscation, because I'm obsessed with it. So what I did is I wrote a test harness to basically use the tool and generate thousands upon thousands of samples, and then immediately test, does it execute properly? Does my syntax actually work? And then, did I detect this with my set of well-defined rules? And so this is the exact test harness that I use for developing all of the detections that we have in all of our endpoint solutions and network solutions for this that I spent like the better half of a year working on. And so this was released with the project as well. So any defender can go and run this to generate samples, or I published over 4,000 samples of obfuscated code from minimal obfuscation to maximum obfuscation in text files or event log files for sysmon EID1 or security 4688. So you can literally take those files, and without running any of my PowerShell code, you have all these sample executions of this content to start writing detections against. So the main takeaways, attackers love obfuscating stuff. It's cheap, it's effective. I don't see it going away anytime soon. Command.exe has a lot of new tricks that have actually been around forever that you can put together and do some really crazy stuff with. And we as defenders have to match the level of creativity that attackers go through. If they're doing really tasteful obfuscation, then why can't we also do tasteful detection? By no means am I saying it's easy, because it's not, and that's why we all have jobs. But yeah, I really hope that this overview is helpful and that the white paper will give you a lot more insight there. I'm on Twitter, and please hit me up for questions or anything like that. And I just want to say a huge thank you to Hack in Paris and the whole crew for having me out here for your time, and also to my team, the advanced practices team at FireEye Mandiant. And then a huge thanks to my wife, Paige, because this was over 1,000 hours of work. That's not the most fun thing to watch me just code many hours every night for like 9 months. It was a huge effort, and I just really want to say a big thank you to her for supporting me in doing that. And so with that, again, I'm available on Twitter. Here's my blog. The code and white paper are linked here. Before we see if anyone has questions, I just want to say again, thank you very much. I really appreciate your time and attention.